Let me start with something uncomfortable. Most of what you learned in school, not outdated, not incomplete, was wrong. Not the facts themselves, necessarily, but the entire method. The framework. The thing that was supposed to teach you how to think. And Richard Feynman spent his life proving it. The silence in Rio. In 1952, Feynman was invited to teach physics at the University of Rio de Janeiro. The students were serious. Diligent. They attended every lecture, took meticulous notes, memorized every equation their professors gave them. Their grades were excellent. Their recitation was flawless. Then Feynman asked them to explain what any of it meant. Silence. Not hesitation, silence. Complete, total, revealing silence. He tested them. Asked a standard question about light reflecting off a surface. One student finally raised his hand and recited a sentence he had clearly memorized months earlier. The light that reflects is perpendicular to the surface. Word perfect. Completely correct. No idea what it meant. These weren't struggling students. These were the top performers in the system. And they understood nothing, because understanding was never what the system asked of them. It asked for accurate repetition, and that's what it got. And surely you're joking, Mr. Feynman, he described what he eventually concluded. The students had memorized everything, but they didn't know what anything meant. The entire system was theatrical. Teachers pretending to teach. Students pretending to learn. Degrees awarded for successful pretending. If that sounds familiar, it should. Because the same thing happened to you. What your father should have taught you. Feynman's father was a uniformed salesman. Not a scientist, not an academic, not a credentialed expert of any kind. But he understood something that almost no school in the world teaches. They used to walk through the woods together, and his father would point at birds. See that bird? In Germany it's called a Holzenvogel. In Chinese it's a chongling. In Portuguese something else entirely. You can learn its name in every language on earth, and when you're done, you'll know exactly nothing about the bird. Then he'd explain what was actually happening. The way the bird pecked at its own feathers, pulling out the lice that fed on the protein there. The lice that laid eggs and multiplied. The bird spending nearly half its waking life just trying to stay clean. One conversation. One walk. And Feynman grasped something that most people with advanced degrees never figure out. Knowing the name of something is not the same as knowing something. Schools are built on names. Terminology, labels, definitions, classifications. The more specialized the vocabulary, the more educated you appear. And the system rewards you lavishly for mastering the vocabulary, while never checking whether you have any idea what the words actually describe. The glass of ice water. January 28, 1986. The Space Shuttle Challenger exploded 73 seconds after launch, killing all 7 crew members. NASA assembled its top engineers. PhDs from MIT, Stanford, Caltech. Months of investigation followed. Complex reports, sophisticated analysis, dense technical language. Then Feynman walked into the hearing room carrying a glass of ice water and a small piece of rubber O-ring material. He dropped the rubber into the ice water. Waited. Pulled it out and demonstrated that it had lost its flexibility in the cold. I believe that has some significance for our problem, he said. 60 seconds. No equations. No jargon. No prestigious credentials required. He had demonstrated, simply, undeniably, in front of the nation, what months of expert investigation had somehow obscured. The O-rings failed in cold temperatures. That was the cause. That was all there was to it. The engineers weren't stupid. They were trained. Trained by the same system that trained you. Trained to make things complicated, to hide behind technical language, to confuse the appearance of rigor with actual understanding. Because if you can make something sound complex enough, no one questions whether you actually understand it. Feynman's glass of ice water was not a triumph of intelligence over ignorance. It was a triumph of clear thinking over trained obfuscation. And the difference between those two things, between a credential and genuine understanding, is what the entire education system is designed to prevent you from discovering. What schools actually taught you. Here is the honest accounting of what 12 or 16 or 20 years of formal education produced. You learned to sit still for extended periods and comply with instructions. You learned to produce exactly what authority figures demanded, no more, no less, no original interpretation. You learned to memorize information for specific purposes and release it afterward with no lasting trace. You learn that the right answer is whatever the teacher says the right answer is. And most consequentially, you learn to nod when you don't understand, because admitting confusion feels like failure. That last one is the real damage. Feynman never feared looking stupid. At Los Alamos, surrounded by the greatest physicists of the 20th century, he would ask basic questions in the middle of seminars. What exactly do you mean by that? Can you explain that more simply? I don't follow this part. Other scientists occasionally found this irritating. They thought he was slowing things down. His simple questions regularly exposed fundamental flaws in reasoning that everyone else was too afraid to mention. In his Nobel Prize acceptance speech, he said, "I don't have to know an answer. I don't feel frightened by not knowing things." Schools taught you the opposite. They taught you that not knowing is shameful. That confusion indicates inadequacy. That questions make you look unprepared. So you mastered the art of appearing to understand, and you've been performing that art in meetings, in conversations, in your own internal monologue ever since. The technique that isn't a technique. What people call the Feynman technique, his famous method for learning, wasn't a revolutionary insight. It was simply a refusal to lie to himself. Take a concept you believe you understand. Try to explain it in plain language to someone with no background in the subject. Find the places where your explanation collapses. Go back and actually learn those parts. That's it. Schools do the reverse. They give you technical language first, which makes you feel sophisticated. They test whether you can reproduce that language, which makes them feel like they taught you something. They never ask you to explain anything simply, because doing so would reveal that no one in the room actually understands it. Not the students, and often not the teachers. Try it now. Pick anything you were supposedly taught in school. Anything at all. Explain it out loud as though you're teaching a 12-year-old. No jargon allowed. No retreating into technical vocabulary. Just clear, honest explanation. There are gaps, aren't there? Places where you realize you memorized words without ever grasping the underlying reality they were meant to describe. That discomfort you're feeling is the gap between what you were told you learned and what you actually understand. Schools never produced that discomfort on purpose, because it would reveal they had taught you nothing. So they kept you in the comfortable territory of memorization, where you could feel accomplished without being genuinely challenged. What curiosity actually looks like. After Los Alamos, Feynman was burned out. The Manhattan Project had drained something essential from him. Physics had become obligation, a source of pressure and external purpose rather than genuine interest. So when he returned to Cornell, he made a deliberate decision. He would give himself permission to play again. He would think about things simply because they interested him. No practical application required, no important paper to produce, no professional advancement at stake. He was sitting in the university cafeteria when a student across the room tossed a plate into the air. As the plate spun, Feynman noticed that the Cornell medallion on its rim was rotating at a different rate than the plate was wobbling. He thought, "That's odd. I wonder why." He went back to his office and worked out the mathematics. Not for any reason. Just because it was interesting. That idle, purposeless calculation, done purely out of curiosity about a spinning plate, eventually connected to fundamental principles of rotation and angular momentum that fed into his work on quantum electrodynamics. That work won the Nobel Prize in 1965. The path from a thrown plate to a Nobel Prize ran directly through the kind of unstructured, directionless curiosity that schools consistently treat as a waste of time. Schools separated learning from pleasure. They taught you to associate acquiring knowledge with performance anxiety, with grades, with proving yourself to external evaluators. So you learned to experience learning as stressful rather than joyful. And then you wondered why you gave up on curiosity somewhere around the age of 15. It wasn't a personal failing. It was a designed outcome. Curious students ask questions. Questions slow down the curriculum. A slower curriculum means less material covered, which means lower test scores, which means lower institutional rankings, which means less funding. The incentive structure of formal education is systematically opposed to genuine intellectual curiosity. So they trained it out of you. They called it discipline. The blindness of expertise. There's one more thing that Feynman exposed, and it is perhaps the most counterintuitive. Expertise can blind you. The more deeply you are trained in the specialized language of a field, the harder it becomes to see basic truths. You begin to mistake the map for the territory, the terminology for the underlying reality the terminology was invented to describe. NASA's engineers knew everything about rocket science. And knowing so much, in such specialized detail, made it nearly impossible for them to see what Feynman saw within 60 seconds using a glass of ice water. Fresh eyes, no investment in the existing framework, no professional identity tied to the current explanation. He wasn't smarter than the engineers. He just hadn't been trained to not see it. Your education gave you maps. Very detailed, very authoritative maps. And it taught you to worship maps rather than to check whether they accurately describe the territory they claim to represent. So when you get lost, in a career, in a relationship, in trying to understand your own life, your first assumption is that you misread the map. It rarely occurs to you that the map itself might be wrong. The vindication. Here is what all of this means for you specifically. Every time you struggled to understand something that everyone else seemed to grasp, that wasn't a personal intellectual failure. It was the system exposing its own limitations in you. Every time you forgot material immediately after the exam you studied it for, that was accurate feedback. The material was never understood, only temporarily stored for retrieval purposes. Every time you felt like an imposter despite your credentials, your instincts were correct. The credentials and the understanding were always separate things. Feynman demonstrated an alternative approach across his entire career. Learn through curiosity rather than obligation. Ask real questions rather than acceptable ones. Explain things simply rather than making them sound impressively complex. Test your understanding against reality rather than against what authorities say reality should be. Admit confusion honestly rather than performing comprehension. He wrote, "The first principle is that you must not fool yourself, and you are the easiest person to fool." Schools were built on teaching you to fool yourself. To accept complexity as evidence of intelligence. To trust credentials over direct observation. To value knowing the name of something over knowing the thing itself. They could do this because everyone around you was doing it too. The mutual pretense made it invisible. But the pretense is documentable. Demonstrable. Feynman demonstrated it in Brazil, at Los Alamos, at the Challenger investigation, in lecture halls and seminar rooms and papers across 4 decades. The evidence is overwhelming. The only question is whether you're willing to see it, and whether you're ready to start learning the way you were actually built to learn, before they trained it out of you. You were born curious. They had reasons to suppress that. Now you know what those reasons were.